Well, hey Marine, how are you doing? Hope you are doing well and your family are doing well. Today we're going to be talking about relationships in the ocean and also talk about sexual reproduction, asexual reproduction, because without the ability to reproduce, species would go extinct and they wouldn't have the relationships in the first place. So I'm going to take the webcam away though for most of this video because I got a lot of pictures to show you and stuff. But we're going to be talking about lesson 17 today in the video. So relationships. I'm not sure when your first relationship was, whether it was like in elementary school and a kid pushed you down the playground and hurt you, and they're like, oh, it's just because they like you, and that's ridiculous. Anyways, or if it was in high school, obviously you're in high school right now. But yeah, relationships are tough, and the Bible has a lot to say about them, about how to have successful ones, parents and children and wife and husband and between friends. God's word is full of rich knowledge and advice, but of course, His word is most about Him wanting to have a relationship with us. But when I think about relationships, I think about Philippians 2:3-4. Do nothing from selfishness or empty conceit, but with humility of mind regard one another as more important than yourselves. Do not merely look out for your own personal interests, but also for the interests of others. So every day, are you just looking out for what you want to look out for and your own personal desires and dreams, or are you looking out for other people around you? So Symbioses, that's what we're going to talk about. We talked about it already a little bit with Finding Dory project a long time ago, but any relationship in which two species live closely together is called a symbiosis. Symbiosis, which means living together. There's three different types: mutualism, parasitism, and commensalism. First off, mutualism. A great example, best example, most familiar example probably is uh, Nemo, his dad. What's his dad's name? Oh, that's horrible. Marlin? Martin? I don't know. That's horrible. I have a little girl. I should know that. Anyways, nonetheless, clownfish and sea anemone, mutualism, they both benefit. Clownfish gets a home, sea anemone gets protection. They both benefit. Mutualism. Parasitism is when only one benefits, the other one is harmed. Fleas, ticks, lice. Speaking about relationships, some relationships are parasitic. I know some of you probably have seen that or experienced it tragically. Yeah, sometimes people are just in it for what they can get out of it, which is obviously not righteous nor beneficial to you if you find someone like that in your life. So tapeworms, like tapeworm is an example of parasite. Fleas, ticks, lice. Here's an example of a tapeworm life cycle in the human being. So this is a scanning electron microscope right here. Color's been added falsely just to help us understand. And how in the world do you get this? Well, eggs contaminated by livestock. Those eggs develop into larvae and infect the animal's muscular tissues. Larvae form cysts in muscle tissue, and those cysts survive if meat's not cooked to a proper temperature. And so, if you eat undercooked meat, you could ingest those cysts. Those cysts develop into adult tapeworms, and they will absorb a lot of the nutrients that you eat. You'll get super sick and weak, and there's some really graphic videos on YouTube about it. But that's an example of a parasite. Here's an example of an isopod that's a parasite on a fish's head. That's an example of a parasite in um, life, marine systems. Commensalism is when one species benefits and one species literally does not care. So barnacles attach themselves to whale skins. No known service to the whale. They do not harm it. These little birds, the egrets, the cattle, stomp on the ground, eat, pull up the grass, and when they pull up the grass, little bugs come out. Those egrets are like all you can eat buffet, Hakuna Matata style, and so they eat all those bugs coming out. Remora fish on a shark. Shark doesn't eat. Sharks don't make happy plates. They're kind of messy eaters, slinging stuff everywhere. And so those scraps, remoras, are more than happy to clean up. So questions part one. I'll be asking you questions in this video. Questions part one. Email me 3 examples of symbiosis in Florida systems, marine systems specifically. 3 examples. Tell me what it is, either mutualistic, parasitic, or commensalistic. I'm not sure if that's a word, but yeah, you can get it. Intraspecific versus intraspecific are a couple of vocabulary terms that your book talks about, but relationships, if they involve the same species, it's intra. So I like to think of it as same. So same, you see the A right there, intraspecific, and then different is interspecific, intramurals. Some of you might be wanting to play that in college. Interspecific versus intraspecific. So here's just some pictures here about various relationships. So there's a shark with the remora. There's a remora suction cup right there. That's how it stays attached. Pretty crazy. Some crab make their home in living coral and various, things like that. It's cool. There's famous Nemo and his dad, Martin. That's horrible. I don't know that name right now. It's so sad. Here's some examples of parasites. I don't know if you ever had a tick. Don't rip it off. The head might stay in. But yeah, Lyme disease, not good. But this picture right here is illustrating one of the creepiest creatures on the planet. It's a tongue-eating louse, isopod. Literally, it gets inside of a fish. I won't tell you how because that's part of your next question set. And it eats off the tongue and replaces itself as the tongue. And so when the fish eats, it's like, oh, it's psych, just kidding. I'm actually eating. And so, yeah, questions part 2, just because it's crazy interesting. Symathoa exigua. I think it's that way. Classification, domain through species. No, I want you to classify it. I already gave you the genus and species there. How does it even get inside of a fish, though, and eat the tongue off? So tell me that. And then is there any way for a fish to get rid of it? There's a cool video right here that I'll put in the description about that organism. Crazy, creepy, weird, but you'll learn some stuff. Intraspecific relationships. For a species to avoid extinction, what must happen? Well, of course, that species needs to successfully create babies, more of itself. And those babies need to outnumber the species that are dying. A lot of species are on the endangered species list, of course, are having issues procreating because of genetic issues and low genetic diversity and environmental change and all sorts of stuff. But there's 2 different types of reproduction, asexual and sexual. Asexual is basically creating clones. One parent, and that one parent divides or somehow creates 2 identical offspring. NPR has an amazing video. I showed some of you this previous years, but about the Hydra. I'm not talking about SHIELD here, but Hydra, literally. Hydra, there's a video about it being claimed it could be immortal because it replaces itself so often. You can check that video out if you type it in YouTube. But here's the 3 examples of asexual reproduction. You have binary fission, budding, and regeneration. So the Hydra bud, so literally budding is when a little small baby grows on the side and then is removed and then develops into its own organism. Regeneration is when parts of an organism, if it's cut in 2 or many pieces, they develop all into adult organisms. Some sea stars do this. Hydra actually does this too. There's a flatworm that does this. Binary fission, some species, divide in 2 in a process, paramecium, in a process similar to mitosis, not exact, but similar to. So here's an important table here. Asexual versus sexual. Basically, the biggest things about it is asexual is one parent giving rise to kind of clone organisms. Sexual is 2 parents involving gametes, sex cells and egg cells. And that increases genetic diversity, however, it costs way more energy to do. And so there's advantages and disadvantages to both. Asexual, you can get a lot of organisms in a short amount of time. Sexual, not so much, but you do have that genetic diversity to withstand environmental stress and change. Here's an example of coral. Coral are sessile feeders, which means they remain stationary when they feed. And what they attach to is considered the substrate or a hard surface. So some other terms in your book for chapter 17 is spawn. Spawn is the eggs and sperm released or deposited into the water by aquatic organisms or animals. As a verb, to spawn refers to the process of releasing the eggs and sperm, and the act of both sexes is called spawning. So here's an example of coral releasing gametes into the water. Here's another picture, some eggs being released. Another picture here. So that's spawning. Of course, sexual reproduction involves those gametes, eggs and sperm. There's wonderful videos about penguins taking care of their young. When both parents are involved in the animal world, taking care of the young's chance of survival go up. And so if you've seen the extreme lengths the penguins go through to make sure that egg is warm and hatched and the baby has nutrients, they are trying to increase that chance, that baby chick's chances of surviving. And so another great example, another crazy example of sexual reproduction are seahorses. So literally the male carries the developing seahorses, which has been the topic of discussion for years. But how does it work? Well, the male carries the eggs, but he doesn't make them. So after a male and female seahorse spend time courting, the female deposits her eggs inside the male's pouch, and he fertilizes the eggs inside the pouch. His pouch is actually a complex organ that regulates temperature, blood flow, and water salinity for the eggs as they hatch. So the babies are as prepared as possible for life in the ocean. Why in the world would they do this, though? What would be the advantage from a natural selection point of view, an evolutionary point of view? Well, perhaps making more babies. One theory is that male seahorses carry the babies is that this gives the species the ability to make more babies. He's carrying them, and the female seahorse is making more eggs. And so, therefore, it increases the chance of making more babies. Because, of course, struggle for survival, most of these young seahorses ain't going to make it. And so you need to create as many as possible to enhance the ability for some to survive. Shark species, they reproduce sexually, but sometimes they do an external development, which means an egg is released or via like an egg case or an egg capsule. So it's colloquially known as a mermaid's purse or devil's purse. You can kind of see why that would be right here. It's a casing that surrounds the fertilized eggs of some sharks, skates, and chimeras. They're made of collagen, which is a protein that helps elasticity. So some develop inside the female. Some females provide nutrients, some don't. If we were to dissect the dogfish, you would have seen baby sharks. If you had a pregnant dogfish, you would have seen baby sharks ingesting a yolk sac for nutrients. Either way, when the young are born, sharks are like, you're on your own, peace. And so questions part 3. I want you to give me one example of a shark species with external development. For example, they release a mermaid's purse. And I want you to give me one species of shark that develops internally. The last thing that your book kind of talks about I want to discuss with you is whales. Whales reproduce sexually, of course. Long time, intense process, beautiful animals. But the young nurse, they're mammals. They're the young nurse. And so I just, I don't know if you ever wanted this, but I want you to research this a little bit. The answers are pretty amazing. But how in the world do whales nurse underwater? And there's a video here that I also post in the description about they put a camera on top of a humpback calf, and they actually, I think for the first time, or at least, it's a very rare video of a humpback calf nursing underwater. And so I'll put that video into the description. But yeah, it's interesting. But yeah, that's your last question for this video. How do whales nurse underwater? So anyways, until next time, guys, I hope this was helpful. I hope you're doing well. We're almost at the finish line. Keep going strong, okay? Talk to you later.